is. So this here, that's the R shell. I can type in this pane, the console pane, exactly what I typed earlier, and it works exactly the same thing because this is exactly the same thing. So now, why run RStudio instead of just R? Well, that's because there's all the other stuff around. And here I have a script, so a bunch of commands written into a text file, .r. And here I have a little pane that will show some help. For instance, you can get help on any object or functions in R with a question mark. So if I type question mark sum and then enter, the help or the man page, the documentation page for the function sum will appear in this pane here. If you create some graphs, they will also show in this pane. And as you create objects, they will appear in your environment. So that's what an IDE is. It's a nicer interface to run something. The code that I'm going to be using, so maybe I could do this, is all in this workshop. So you can type the code directly into your console, or you can also just copy it by clicking on the little clipboard symbol and then paste it in your console, whatever is most convenient. So just remember that all of the code I will be running is on the website and you can just copy paste it. Now, to make things a little bit simpler, instead of having to copy paste throughout the workshop, I created a script with all of the commands that are in the website, but don't feel you have to write this script in a panic, it's all in the website. One nice thing about the RStudio IDE is that if I want to create an object, for instance, if I want to assign the value 3 to a new object that I am calling A, I can type it here in the console. But if I have it already in a script, with the shortcut Control Enter, I am directly sending the command from the script into the console. And so that's really super convenient. I can execute the script either line by line or function by function, depending on the settings, simply with Control Enter. And as I did this, notice that in the environment, suddenly something has appeared. I have created a new object, an object A with the value 3, and it has appeared here. So the global environment that you have here, that's all of the objects that are currently available in the session. So that means that now I have this object A, and if I go to my console and I type A, enter, I get the value 3. Or if I type A in a script and I press Control Enter, I am sending automatically the command to the console. Is everybody with me, except for the people who can't log in? And I apologize once again for that. But is everybody otherwise clear with what's going on?
No, I did not get it. Could you please explain the part once more?
The what, sorry?
The assigning of a value to A. Right,
yeah. So it's similar to what happens in a lot of programming language. A is a name, it's a reference, and 3 is a value, and that value will be written in memory somewhere on the computer. But by assigning the value 3 to the name A, now A, I create a variable, and A represents the value 3, and I can recall it and use it as in, for instance, A plus 2 equals 5. In a lot of programming languages, this assignment is done with the equal sign. And you can also do that in R. So these two commands are exactly equivalent. But, right, so the code is all on the website. I can pass the link again.
Yeah,
you beat me to it, Ross. Yeah. So all of these commands are here. And you can copy them by clicking on the clipboard if you wish.
Yes, can I just, when you say you can type it here, if you can show, because on the screen, I was not able to follow where you're typing.
Right, so you can type directly
when you say
in the
this
console.
Here, if you could just point it out, it'll make it easier.
So do you see the console on your screen?
Yes, yes.
Okay, so you can, for instance, copy from the website. I'm copying this, and then go to your console, paste it, and run it. That's one way.
Okay.
Or you can type it directly in the console. So this left arrow, that's the assignment sign in R. It plays the same role as the equal sign. So you can use equal instead if you want. But if you want to use the assignment sign, which is by some R purists considered to be nicer, and it makes things a little bit easier to read because the equal sign can have multiple meanings, you can type it in RStudio with Alt and the minus sign. So if you type Alt and minus sign at the same time, it will automatically create the little assignment sign. So you can type the commands directly in your console. You can type them, or you can copy them from the website and paste them. So you can go, you can do everything directly in the console for this workshop because we will be using very basic commands. Now, you can also write scripts, and a script is a text file with the .r extension. So if you write a script, then this is what I did here. You can send code directly from the script to the console simply by typing Control-Enter. So for you, because you don't have a script pre-made, this is not the workflow you'll be using for this workshop. For today, you'll be copying from the website and pasting it in the console, or typing directly in the console. But I wanted to show you how easy it is to send commands from a script to the console to show you the friendliness of using RStudio. Does things make a little bit more sense? Sorry if I was a bit confusing with that. Is everybody a bit more clear of where to find the code and how to run it? Can someone answer, please? I feel a bit alone.
Yes, it's much more clear, at least for me. Thanks. Okay,
thank you so much. Thank you. Okay, don't hesitate to unmute and ask something else if I'm not being very clear. Because yeah, I acknowledge that the fact that I'm using a script and you don't have a script made it a bit confusing. I thought that it would make it simpler, but in fact, it was a bit confusing. So that's my bad. So as I mentioned, the assignment, this sign here that you can type in RStudio with Alt minus is equivalent to equal. In other languages, in Python, etc., you will see the equal sign instead. And you can use equal sign in R too, if you prefer. So I have now this variable in my global environment here. I can remove it with the rm function. So a function is it's the equivalent of a verb for a language. It's something that does something. It's a command that will run some code that was defined in the R program, and functions are always followed without any space by parentheses. Some functions run without anything in their parentheses. What's in between the parentheses are called arguments. So some functions run without arguments. Some functions take arguments. The RM function, I'm going to go in the console, needs an argument. So if I give to the RM function the argument A, it will remove the object A. So look at what's going on in my global environment. I run this, I don't have any object A in the global environment anymore. So if I type A in the console now, I get error, object A not found. It doesn't exist because I have deleted it. Okay. Anything that follows a hashtag is a comment. Comments are incredibly useful because if you share your script with someone else, or for future you, when you revisit a script after a couple of months, it is incredibly useful to know what's going on in the script. Why did I do that? What does this mean? What does this do? So comments are incredibly invaluable, and you should really make use of them. However, as far as the R program is concerned, they don't play any role at all. Anything that follows the hashtag is perfectly ignored by R, which is why when I ran this, it just created the variable A. Anything that was after this didn't change anything. So you can have comments that occupy an entire line, or you can have a comment that comes after some code. There is some help functions that you can access. That's how I started the workshop on this page. You can use the help function or the question mark to access the help file of something. So for instance, earlier on, I wrote question mark help or question mark sum in the example I ran, and you can see it opens the help on the sum function. Since I've been using the RM function, I can look at the documentation for the RM function with question mark RM. So here, notice how I'm not using the parenthesis for the function, just the function name itself. Okay, so I get a description of the function, where it is found, what it does, and some example usage with a detailed description of all of the arguments. So this is incredibly invaluable. And at the end of the documentation, you always have some examples that can be run directly. You don't need any special data or anything to be able. Yeah? Yeah, someone had a question? Okay, you can run those examples without needing any data or anything. So sometimes reading the description of what a function does can be tricky. Sometimes you read it and you're like, what does it really do? Running the examples can be tremendously useful, because seeing what actually happens when you run the code might be like, yes, okay, that's what it does. If I type help RM, it does exactly the same thing. So question mark RM and help RM are equivalent. Question mark RM is just a way to run the help function. So that's a great question. This one simply means that this is line number 1 of the output. Here, because A has only one value, it's just the value 3, there's only a 1. But later on, I don't know if in this workshop I will create things big enough, but if you create, say, a data frame or a matrix, and your output has a lot of lines, you will see the line numbered 1, 2, 3, and so it's a visual help. And if you have a matrix and you have several columns, you can see also the columns showing up. So R always tells you how to index element. Technically speaking, it means that if I were to index the object A like this, so A, and then without any space, what is in here, I will get 3. So it's the index of the elements in the output. Okay, so if you are brand new to R, if you want to get to the general documentation, there is this help.start function that you can run. So this is a function, notice, that does not take any argument. So there's nothing in the parentheses. So you can run this, and that will take you to the main R documentation page. And those are hyperlinks, so you can click on an introduction to R and etc. So if you're really brand new and you want to explore the introductory manuals to R, this can be a nice starting point. Any questions so far? So let's talk a little bit about data types, because we've created one object so far, A, but what is A? So if we want to have some information on an object, so in the IDE, you can over A, and it tells you, okay, it's a numeric of 56 bytes. But if you want to have some formal description of A, there are various functions that give you some information. One is type of. So if I write type of A, this tells me double. So what is a double? A double is the R terminology for a double floating point number. So it's a numerical that is not an integer. If I look at the structure with str of A, it's a numerical. So technically, it's a vector of size 1, which is a numerical, and its value is 3. If I look at the length of A, it has a length of 1. It has a length because every single value in R is actually a vector. It's just a vector of length 1. But the fundamental basic element in R is a vector. So here, a vector of length 1. Okay. So what are all of the data types in R? Well, some data types are homogeneous, meaning that if it's a collection, every single element is of the same type, and some are heterogeneous. And then they can have multiple dimensions. So the smallest type is the atomic vector. So A is an atomic vector. So it has only one dimension and it is homogeneous. Let's explore atomic vectors a little bit more. You can create an atomic vector with this C function. What is this function? So that a question mark C. C allows to combine values into a vector or a list. So if you put a bunch of values of the same type, here, for instance, a bunch of numbers into C, pass them as arguments, you create a vector. So here I am assigning a vector with 3 values, 2, 4, and 1, into an object that I'm calling vec. Why not? Vec for vector. Okay. If I run vec to see what it looks like, vec is a vector with 2, 4, and 1. So if I look at the length of vec, what do you think I will get? Can someone tell me what I would get if I run this? You can type in Slack, or you can unmute.
3.
What's your guess?
3.
Yeah, exactly. Perfect. Yeah, it's a vector of length 3. Totally. Yeah. If I look at its structure.
Excuse me, just.
Yeah.
When you said vector equal to 2, 4, and 1, what is the C in front?
C is a function. I opened the help documentation for it. It's a function that allows to create a vector or a list by combining values. So here, what I'm doing is that I am creating a vector by combining, C stands for combine, the values 2, 4, and 1. So C is a function.
Okay. Thank you.
Yeah, no, that's a great question. This C function is a bit intriguing. I was a bit puzzled by it when I learned R at first. So that's a very good question. So if I looked at the structure of vector, I can see that it's a numerical vector. It goes from 1 to 3, and it has the elements 2, 4, and 1. But I can create vectors of different types. For instance, true, false, and NA are Booleans in R. NA stands for not available, and that's the object that R uses whenever a value is missing. So let's try this. So if I run this and then print vec again, you can see that I have overwritten the value of vec. So you can assign a different value to the same name. Vec previously was a vector of numerics. Now vec is a vector of Booleans. So you can totally reassign a new value to the same name. You can recycle names. So if I look at the structure of vec, now it is a logical vector with true, true, NA, and false. So the length of vec here would be 4. Note that indexing in R starts with 1. It doesn't start with 0 as in other programming languages. And this is why I have, when I looked at the structure of vec, I have logi or logical, that's the type, and I have 1, 4, because these are the indices 1, 2, 3, 4. So the first element, true, is 1. So to index vec, for instance, if I type vec and then 1, I am here indexing the very first element of that vector. I am getting true. That's the first element. How could I get this NA element? How could I index NA out of my vector? You can again unmute or, yeah, exactly. Vec, and then I index 3, that would return NA. Yeah, totally. That's called vector indexing. And 1 here or 3 there, that's called the index. And if I look at the type of vec in this case, it's a logical, because I have added logical values. Another type are strings. So here, something weird is going on. This is a string, is between quotes. So if I type of, this is a string, that's called a character. Strings in R are called character. Okay, now here I have 3. And if I type of 3, I get a double. What happens if I mix various types here? Well, let's try it. And then test here is another character. Okay, let's try that and see what happens. Okay, I didn't get any error message, But now if I print vec, this is what I get. This is a string 3 that is now between quotes and tests. So because a vector, an atomic vector is homogeneous, it cannot have elements of different types. So R has automatically converted the numeric into a character to be able to run this function. So it is a character vector, and R has turned 3, the double, into a character. If I do type of, and then between quotes 3, that's a character. The quotes turn anything you put in it as a character. So now vector, if I want to index the element 3 here, that would be the second element. So vec2 would return 3. Note that you can navigate your history very easily in the console with the arrow keys. So if you want to rerun something or modify it, instead of having to retype, you can use the arrow keys. So if I look at the type of the second element of vec, it is indeed a character. Because atomic vector are one-dimensional. They have a length, so they can have a length of 1 if there's just one value. That's what happened when we created A. They can have multiple values, so they have a length, but they have a single dimension and they are homogeneous. Does that make sense? Similarly here, if I run true, 3, and false, something maybe even more bizarre happens. I get 1, 3, 0. Well, that's because the Booleans are in fact integers. True is the integer 1 and false is the integer 0. So when I threw in an integer in the mix, are converted true to 1 and false to 0. So if I look at the type of vec, they're doubles, and their structure, numerical vector 1, 3, 0. So now let's have a look at data frames. We don't have time to go over every single data type in this short introduction, but I want to talk about data frames because data frames are a very, very important data type that's super useful whenever you have data, for instance, in an Excel file with a bunch of variables in different columns with the values in various rows. That's a kind of tabular data that you will use into a data frame. So a data frame has 2 dimensions, have columns and rows. And a data frame is heterogeneous. Indeed, if you have tabular data with a number of variables, the type of each variable is the same, but the type of different variables can be different. For instance, you can have data with a column with date, for instance, and then a column with temperatures, and a column with country names. So the column with country names could have the type character, but the column with temperatures could have the type double. So all of the values in the temperature variable, in the temperature column, would be doubles, but various columns have various types. So it's a 2-dimensional object that is heterogeneous. So let's have a look at that. You can create a data frame with the data.frame function. To create a vector, we used the function C for combine. To create a data frame, we use data.frame. And then in the data frame function, each argument will represent a variable, so a column. And the name of the variable, or the header of your column, if you want, is written at first, and then the values in it. So here my data frame will have two columns, two variables, one with Canada, USA, Mexico, and one with a variable that I called var, because I don't have a lot of imagination, and some numericals. So you can imagine that there are temperatures or just whatever. So let's try to run this. Okay. Now let's print our data frame. Okay, so I do have a nice little data frame with two variables, country and var, and the countries and those mysterious variables. Okay, if I look at the type of that, I get a list. How strange is that? I created a data frame and R is telling me it's a list. Well, that's because as far as R is concerned, a data frame is actually a list of vectors. Country, that variable, that column, is a vector. Variable is also a vector. And in fact, a data frame is a list of those vectors. So that's why you get list here. And that makes sense because Canada, USA, Mexico, they're all of the same type. That's a unidimensional thing. It's all homogeneous. So that's a vector, right? So here we just have a list of vectors. And if I look at, so the way you can index a data frame, you can type that, and then the $, and then the name of a variable. So that $ country, that gives me Canada, USA, Mexico, the values of that variable. And this looks very familiar, right? This is how we've been printing vectors all along. So if I look at the type of that variable in my data frame, you will see that indeed it is a character vector. If I look at the structure, yeah, it is what we've seen all along, a character vector with 3 elements. So a data frame is simply a list of vectors. So knowing this, what do you think the length of that will be? What's your guess? Again, you can type in Slack or you can unmute. And don't worry if you do something wrong, there's no shame or anything, we're just learning. So what's your guess? Of course, you can run the code, but if you haven't run the code, what do you think? It's late in the day, it's a busy day, maybe everybody's dead. Ah, okay, some people were typing in the Zoom chat and I was looking at Slack. My bad, sorry, I actually have some guesses. Okay, I have 3, I have 2. Well, okay, let's run it and see who's right. So I get 2. Why is it? Well, because of this. For R, a data frame is a list. It's a list of vector. So as far as R is concerned, this data frame is a list of this vector and this vector. It's a list of the variables, a list of the columns, if you want. So the length of that corresponds to the length of the list, which is the number of vectors, which is the number of variables, if you want. So that's why I get 2. But that wasn't intuitive at all. So don't worry if you guessed 3. It's not intuitive at all. I can look at the dimension of that, and that will be much more intuitive. 3, 2 gives the number of rows and then the number of columns. And indeed, I have 3 rows, 2 columns. So DIM, that's an intuitive answer here. Any question on data frames or on anything else for that matter? So there is another heterogeneous data type of one dimension, and it's a list. And a list can contain absolutely anything since it's heterogeneous. You can even have lists inside lists. And then when we are dealing with homogeneous data, if it has 2 dimensions, you can have matrices. And then if it has more than 2 dimensions, you can have arrays, 3-dimensional arrays, 4-dimensional arrays, etc. But I won't go into those other types because there's more to R than just data types. So I want to talk about various things. So as soon as you launch R, you have a number of functions that already exist. They come packaged with R, but you can create your own functions. So we've seen the functions dim, length, structure, type of, etc., etc. If you want to create your own function that would do exactly what you want to do, this is how you would define a function. First, you have to give it a name because you want to be able to use it later on. And then you use the assignment sign as you would to assign any other type of object, which shows us that a function is just yet another object in R. And then the key word here is function. Between the parentheses that follow this, the term function, you have to put some placeholders for the arguments that your function will accept. So if you define a function that doesn't accept any argument, here you would have blank, like nothing at all. You would have empty parentheses. If your function will accept a single argument, you'll have a single element here. In my first example here, I want to define a function that will compare 2 different values. Because I want to compare 2 values, this function will accept 2 arguments. So I need 2 placeholders. So I've been calling them X and Y, but I could have called them A and B, value 1, value 2. It doesn't matter what you put in here, they're just placeholders. And then there are those curly braces. And in the curly braces comes the body of your function. So that's the commands that will be run whenever you call that function. Because I want this function to compare 2 values, I use the code X, which is the placeholder I've been using here. If I had used value 1, value 2, I would here write value 1, value 2. And in between, I put this double equal. Double equal in R and in a lot of other programming languages allows to test for equality. So it returns true if the 2 values are equal, false otherwise. For instance, if I remember that A is 3, so if I type A equal 2, I get false. A equal 3, I get true. Okay. So let's run this and look here in my environment. I now have vec, that's the very last object, because I've been reusing the vec name to create the number of objects. So vec is currently this. I have A and I have my data frame that I can expand here with a little arrow, and I can even look at it thanks to this very convenient little whatnot here, if I want to see it in something that looks like an Excel sheet, which is kind of nice. Okay, now look at it as I run this function definition. Okay, now I have that function here that has appeared in my global environment. And if I click here on this little symbol, I can see what that function is. So that's kind of neat. So, okay, now that I have defined it, I can use it. To use it, I use it the way I would use any other function, like a function that I haven't been defining myself. So I put parentheses right after the function name. And between, it's a function that needs 2 arguments, I need to pass 2 arguments to it. If I run compare with nothing, well, I get an error message. If I run compare with just a single element, I get an error message. It's a functions that require 2 arguments. That's why I had this here. So if I run compare 2 and 3, I get false, because what that runs, well, it runs what was in the body of the function. Now, of course, it would have been just as easy to run 2 = 3 in this case. Defining a function with just 1 mini command doesn't make that much sense. But usually, functions will have a bunch of commands, and they will run much more complex stuff. And the advantage of writing a function is that instead of copying it and pasting a bunch of code, a lot of times you can then reuse your function and you can apply it to all sorts of objects in a much more in a much better way. Copying and pasting is always a big no-no in programming because it's prone to error. So it's inelegant, it's tedious, it's a lot of copy paste, but it's also prone to error. Because if you decide to change the code, chances are that you will make the change in some of your copies, but not all of them. So whenever you catch yourself copying and pasting in programming, stop yourself and be like, okay, maybe I should write a function instead, or maybe, like, there are many ways to avoid copying and pasting. Just stop yourself whenever you're doing it and look for better options. Any questions on functions? So we are slowly running a little bit out of time. So just know that you can also define conditionals and loops in R. If you're familiar with other languages, it will all make a lot of sense. If not, you can run that code later on your computer if you install R, or R and RStudio if you want to be fancy. But let's talk a little bit about packages. So as soon as you install R, there's a lot of functionality that gets installed. There's all of the functions that are predefined and the number of, there's lots of stuff that comes with R. But because R is open source, a huge community of people, a lot of them in mathematics, statistics, biology, linguistics, etc., have been developing additional functionality for R, and all of this extra code is packaged into a package. So a package is simply some additional code that can be loaded, that can be installed and then loaded into an R session to add additional functions, additional variables, additional data, etc., etc. So to look for packages, well, you can just Google. Google is certainly a way to get to a lot of results. There is also this package finder that you can play with. And a lot of the time, really, you will learn of packages just using R with your peers, reading the literature, looking at the method sections. And the good thing R being open source is that, of course, all of those packages are also open source. And so you can install them to reproduce people's method and to apply all of this added functionality to your own data. There is also a list of CRAN packages. So CRAN is this standardized R repository. Not all our packages are in CRAN, but if you create a package and you want to have it go into this central repository, it has to be well documented. It has to pass a number of tests. It has to pass some checks, basically. And that's really great. Other languages don't have this high standard of a big package repository. And that's something that I really think R got brilliantly. Everything that is in the CRAN archive is very well tested, well documented. It's really great. So you can install packages outside of CRAN, but most, if not all, packages you will install will come from this, and you can be sure that they follow the same structure. For instance, when you install a package and run the help command on the functions that come from that package, the manual will have a very similar structure, because that's one of the requirements to have a package accepted to CRAN. And I think that makes it so useful for the user. So how do you install those packages? If you hear from a friend or a paper that there is this great package that allows to do exactly what you want to do, how do you go about it? So there are some R functions. That's another thing that is really very cool with R, is that R comes with its own package manager. So you install packages or remove them or update them directly from within R. For instance, install.packages will allow you to install a package. You just have to put the package name between quotes and it will get installed. Now, installing a package will download it on your machine and pre-compile it. So it will be on your machine now, but before you can actually use it in a session, you have to load it. And that's actually, that may seem tedious, but it's actually good, because it avoids to have your session cluttered with a ton of stuff. You don't want to have in memory millions of functions that you don't actually need. That would slow down the processes. It's better to only have available in a session what you will actually use in that session. So before all the functions and all the stuff that is in a package that you have installed, before you can access it, you have to load it with the library function. So for instance, if I install a package called readXL that allows to read data into R directly from an Excel sheet, before I can use it, I have to run library readXL. And then in the few minutes we have left, just want to say a tiny word about some resources. So the Alliance has a set of supercomputers, and if you want to run heavy computations that are too heavy to run on your machine, you can apply for an account and run things on the Alliance clusters. And the R page would get you started to run R on the cluster. There are also lots of workshops that we give on this, but this is that would be the reference document on how to get started on the cluster. If you want to actually try things on your machine, if you couldn't run the RStudio server today, or if you're like, okay, yeah, R looks like it's something I might want to use and you want to play with it, well, you can go to the download page and download R for your OS. If you want to install RStudio, you can go to the POSIT site. Again, R is the software. RStudio is just an IDE. A lot of people think that RStudio is what runs the computations. RStudio is this very nice software that makes it friendly to use R, but the computations are run by R. And you don't need RStudio to run R, just to, because there's a lot of confusion about that. There are also some carpentry workshops. So the carpentries are, it's a group of volunteers who teach some programming workshops, and myself and a lot of the people teaching this week are actually carpentry instructors. And there is one workshop that is in particular for R for the digital humanities. So that's really spot on for your needs. So you might want to have a look. And there is a book written by Hadley Wickham, who is a very prolific package developer who belongs to the POSIT team called R for Data Science. And if you're getting started with R, it's an excellent book, and it will teach you R from the perspective of the tidyverse, which is a modern set of packages, and it will get you started with very hands-on, very applied R for the data sciences. How do you load a file? How do you plot some data, etc., etc. And if you want to create some nice-looking documents, you might have heard of Markdown. Markdown is a very easy markup language that allows to create some formatted text with minimal markup. So much simpler than LaTeX or HTML. And R Markdown is a package that allows to intertwine some human text written in Markdown and some R code. And R Markdown, it's been very popular for many years, but now it has actually, the new R Markdown is called Quarto. And Quarto is this really fabulous tool that also works in Julia and Python, and that allows to create Word documents, PDFs, HTML, websites, Reveal.js presentation, LaTeX presentations, etc., mixing code and text. And this entire website that I built is actually built with Quarto. So it's really, it's a new tool, but it's incredibly powerful. It builds on R Markdown that has existed for a long time. And if you're interested in the publishing side of R, I am giving a workshop on Quarto on Thursday. So I encourage you to sign up for it if you want to learn more about that side of things. And with that, I will give you a bit of time for questions. And I apologize once again for anyone who was unable to access our RStudio server.
Awesome. Thanks so much, Marie. I just wanted to remind everyone as well that if you want to try out R, installing R in RStudio this week, and you're running into problems and you want to sort of get a project started, or you want to sign up for an account and try running your code on our clusters because it's a bit heavier, please come on Friday. We're going to be providing some individual help to get projects if you're having problems, or if you're stuck and you want some advice. Yeah, please come to the session on Friday and we can give you some more individual help then.
Right. And in the chat, I just posted the link for both R and the POSIT site. So if you want to run the code in this workshop or play with your own data on your computer, just follow the link for R, install R, and then download RStudio. It's very easy. And then I'm going to pass on Slack the link for this workshop once more. Oops, sorry, I pasted the only for the resource tab. Okay. You can run this code on your own machines once you are set up. You can play with it and play with R. So thank you very much, everyone. And also on Thursday, this one might be fully booked, but I'm also giving a workshop on web scraping with R. But this one might be booked. I mean, fully booked.
Oh, that's right. I said web scraping at the beginning of this one, but this was the introduction to our web scraping tomorrow.
Sorry, there was a question how to change an element of the data frame. Right. Yeah. So I don't know whether I have time for that. Lydia, just kick me out if I'm taking too long. But very, very quickly. So our data frame was called that. We saw that we can index with square brackets. So for instance, if I type that 1, 1, I am indexing from that the first row. The first one represents row 1, and the first column, the second one represents the second column. So I can simply assign a new value to this. So for instance, I can put France here. And now if I print that, okay, I have changed the value of an element of the data frame. So simply, thanks to indexing and assigning, we can modify a data frame. Yeah. So that was to answer Carlos.
Thanks so much, Marie. I also posted, I think in the Slack, some more complicated find and replace solutions. If you're looking to, for example, you have a value in your data frame that you want to change, like a find all and replace in a Word document. So some tutorials for that. Thank you so much all for coming, and thank you so much, Marie, for the tutorial. I think we are going to get kicked out soon, so I'm going to stop the recording.